Today's lesson is an introduction to operations in scientific notation. So we are going to learn how to add and subtract and multiply with scientific notation. We've already been talking about how to divide and compare the numbers, but now we're going to learn how to add today, more specifically. So we're going to use what we know. So to evaluate 950,000 plus 4 times 6 times 10 to the 7th, we are going to first figure out what form 950,000 is written in. Well, that is standard form. That's written in normal number. So that is what's called standard form. And then what form is 4.6 times 10 to the 7th written in? That is written in scientific notation. That first number is between 1 and 10. We have times 10 to the 7th power, so this is in scientific notation. Up next, it says to write 4.6 times 10 to the 7th in the same form as 950,000. So we're going to take that 4.6 and we're going to slide that decimal to the right 7 times according to its decimal, or its exponent. So that's 1, 2, 3, 4, 5, 6, 7. We're going to fill in those spots with some zeros. And then if I rewrite that, we have 6 zeros behind it. Add our commas in every 3. So we have 46 million. Now it says write an addition expression. So if we look back at our original problem up there, we had 950,000 plus this 4.6 times 10 to the 7th. Our addition expression would be the 950,000 plus the 46 million. And then E, explain how you would simplify your expression and what is the sum. Well, to simplify that expression, we would line up the numbers in add. And what is the sum? So we're actually going to do the addition problem. And start at the back, count it every 3 and put a comma. So we have 46,450,000 for our answer when we add those two numbers together. So now we're going to look at a problem where we're going to keep it in scientific notation when we add. So this one says that Paul says that 3.14 times 10 to the 5th plus 2.53 times 10 to the 4th is equal to 5.67 times 10 to the 5th. Is he correct? And explain. So what we need to do is when we're doing an addition problem with scientific notation is we have to find the exponent of both. So this one's a 5 and this one's a 4. So what we want to do is change it to the smaller number. So this 5 has to become a 4. So in order to have that, that just simply means we have to slide the decimal over one more spot so that 5 goes down and becomes a 4. So this is really 31.4 times 10 to the 4th now, plus 2.53 times 10 to the 4th. Now that we have the same exponents, we simply add the numbers in the front. So 31.4 plus 2.53. Remember, when you add with decimals, you have to line up the decimals. So I'm going to fill in that empty spot with a 0. 3, that's 9. 1 plus 2 is 3, and that's 3. So right now I have 33.93 times 10 to the 4th. You just keep that times 10 with the same exponent when we add. So the only problem that I see here is that this is not in scientific notation. We have to slide this back one spot so that we have that number that's greater than 1 but less than 10. So we have 3.393 times 10. Now it's going to be to the fifth because I just slid over to the left to add one more decimal place to that. So that would be the correct answer if we added those together. So if we go back and look, and it says Paul said it was 5.67 times 10 to the fifth. He's a little bit off. So no, he's not correct. And our explanation is, I just showed all of that work, so that's my explanation. But it looks as if he just took the numbers that were out front here and added them together, and then took the larger of the two exponents and just kept that. So Paul made a few mistakes there, didn't change the exponents to be the same first and then add. And we're going to do one more problem here. We'll have 3.82 times 10 to the third plus 1.03 times 10 to the fifth. So in order to add, we have to have the smallest exponent. So we need to change that 10 to the fifth to 10 to the third. So by doing that, I have to move the decimal twice. I have to go from 5 to 3, so I have to move 2 places. So if I slide that decimal over 2 places, I have 103 times 10 to the third then. So that replaces that. So now we have the same 10 to the third in both pieces. We're going to add those numbers out front. So I have to take 103 and I have to add 3.82 to that. I'm going to line up my decimals and fill in empty spots with zeros. Then I'm going to add, and I'm going to bring my decimal down. So I have right now 106.82 times 10 to the third. And that's not in scientific notation because 106 is definitely not between 1 and 10. So I'm going to have to take that decimal and slide it back 2 more. So that means I'm going to add 2 more spaces onto my exponent. And I will have 1.0682 times 10 to the fifth now because I had to slide that over 2 spots. So I have to add those on to my exponent.